Hi everyone, I will be teaching data structures in C and C++ language. So according to the definition, data structures is defined as the group of data elements which provides an efficient way of storing and organizing data in the main memory of the computer so that it can be used efficiently. And some examples of data structures include arrays, linked list, stack, queues, trees, etc. So I will be explaining this definition in detail, but before that, let me summarize what are the topics that we will be covering in this playlist. So the topics are recursion, array, string, linked list, stack, queues, trees, heap, sorting techniques, hashing techniques, graphs. And within the trees, we will be covering binary search trees, AVL trees, and search trees. Now, let us study about the stack and the heap memory in detail. Let us suppose that this is the hard disk drive storage of the computer, and we have a program file saved in this hard disk drive storage. Now, before executing the program file must be brought to the main memory of the computer for execution. So, the CPU of the computer can only access those files, those documents which are in its main memory. Let us get an idea about the main memory of the computer. The main memory of the computer is divided into various memory segments, and each memory segment can be represented as grids that I have shown here. Each cell of the grid is called 1 byte. Okay, now so this is the 0th byte, and this is the 65,535th byte. Okay, so this is a memory segment. Let us assume to be a memory segment uh, which is shown like a grid-like structure, and this is the 0th cell, and this is the 65,535th cell. Okay, so total how many cells are here? The total is from 0 to 65,535 is actually 65,536 cells are there, or we can say this is 65,536 bytes. So this is approximately equals to 64 into 1024, which is approximately equal to 64 KB of storage. Now let us assume that this is the size of the main memory. So I have given a brief idea about the main memory of the computer. Now let us move into the various sections of the main memory, how a program uses the main memory. So this is a segment of the main memory as I have already stated, and the main memory is mainly divided into three main sections: the code section, the stack section, and the heap section. Okay, now let us see how a program file utilizes this code section, stack section, and heap section for the proper execution of the program. Now for that I have taken a code snippet here. Okay, so let us go by the flow of the program. So let us assume that each integer variable occupies 2 bytes of memory, and each float variable occupies 4 bytes. The first line says that declare two variables, one is of integer data type, another is of float data type, into the main memory. Okay, so the all the variables for the main function will be declared in the stack portion of the main memory segment. So we have declared a variable a, and we have declared a variable b. Suppose this is taking 2 bytes, variable a, and the variable b is taking 4 bytes of space. This is called as the activation record of for the main function. This is called as the activation record for the main function. So the next line says that declare a pointer of int data type. Okay, so since integer consumes 2 bytes of memory space, so the pointer of integer data type also takes 2 bytes. So let us declare a pointer in the stack itself. So this is a pointer p taking 2 bytes. So a pointer is basically used to store the address of any of another variable. Okay, so the next line says that this is C++ code for declaring a array of size 5 in the heap memory. The heap section of the main memory should always be used by a pointer. We cannot use directly. For example, the stack section can be used directly when we say int a on the variable will be created in the stack section itself by default. But for accessing the heap memory, we must define a pointer. So I have declared a pointer p in the stack memory. So this is the C++ syntax, and for the C syntax we must use the malloc function. So this uh, basically creates an array of size 5 in the heap memory, and let the address of this array in the heap memory is 500. So the pointer p will basically store the address of the array that is created in the heap memory. Okay, the next syntax is delete. The delete function basically releases the heap memory, basically clears the heap memory when the heap memory is not in use. So the delete function actually uh, releases the heap memory, so it will clear this array, it will release the heap memory and then set the pointer to null. Okay, so this is a good practice. So I have traversed through the entire main function. Once this function is executed by the computer, so the activation record for the main function will be erased from the stack automatically. So I think you guys have got the idea about the stack and the heap memory and how a program utilizes the memory segment of the computer for its execution. Now uh, we will see about the types of data structures. There are basically broadly there are two categories of data structure. Number one is the physical data structures and number two is the logical data structures. The physical data structures includes data structures like array and linked list. The linked list is basically used when we do not know about the size of the total number of values. So how many values we have to store. Okay. The next we have the logical data structures. Within the logical data structures we have stack, queues, trees, graphs, and hash tables. Not hash tools, is hash tables. The stack is a LIFO data structures. Now what is LIFO? Last input first out. Okay, so we will study in detail about stack, queues, trees, graphs, and hash tables. And stack and queues is linear logical data structures. Trees and graphs are non-linear, and hash table is tabular data logical data structures. So this is all for today. For the complete course on data structures, subscribe to this channel. If you find this video helpful, then please like and comment below. So thank you for now. Goodbye.